Hey guys, I wanted to let you know that the manuscript of my second book got approved and it's now on Amazon, both as a paperback as well as it's on Kindle. And the title of the book is Neural Oscillations in Neural Networks, and the idea is to provide you with the fundamentals for those who are interested in using EEG in the world of neural networks, more specifically deep learning or deep neural networks. And the link, I will put it down below if you're interested, and also if you like the book, I really appreciate a review on Amazon because that obviously helps. The book is geared towards a couple of different demographics. One demographic would be that for those who are already very familiar with EEG, but they're not as familiar with neural networks, and they're interested in learning about neural networks, but just the fundamentals. More specifically, what is it that works and does not work with EEG data? Because every data set that you're working with, when you are interested in, for example, using deep learning architectures, you do need to have it set up such that it works with that specific data. And of course, EEG data has its own characteristics, so that's a very specific part that is also covered. Another demographic is that if you, for example, have no understanding of EEG data, but you are very good in computer science and more specifically in neural networks, but you're interested in working with EEG data, then this book also provides a fundamental of EEG. The data, what it is, what type of data it is, and also what is it, how can you actually access data that are publicly available, and they are free. And also the book covers some links to this online resources where there are some legit EEG data that are made available, for example, from different institutions, different labs, different researchers in general. So you don't need to collect your own EEG data, but you can access it from there. Third demographics are those readers who actually don't have any background either in EEG, neural oscillation, or in neural networks, but they're genuinely interested in the space. Maybe you're a student and you're just trying to figure out, do you even like this space or not? And the book is designed such that it's not very technical, because if you want to go really technical, it becomes like several books, in my opinion. And sometimes it's not even feasible to go very detailed in that, because every data set is different and also every person's need is different. But it will give you enough non-technical sort of fundamentals and overview such that you can understand. So the introduction part of the book starts with giving an overview about why this topic is even interesting, and then it goes on to give fundamentals about EEG, where to access the free data that I was just talking about, or if you're interested in collecting your own at a very, very high level, how you could possibly do that. And then it goes on to the next chapter where it gives fundamental of neural networks, and also the differentiation between what's an AI, what's ML, machine learning versus deep learning versus neural networks, what's the relationship there, and also what the differences are at a very, very high level, by the way. So if you already know these things, this is very beginners for you. And then it goes on to looking at what neural oscillation is within neural networks. And in the chapter where it talks about neural oscillation within neural networks, there are 3 different sections there. The first section is covering the top 3 neural networks that work best with EEG data according to the existing body of knowledge. So I looked at a lot of different studies, and these top 3 neural networks appear to work the best with EEG data. The second portion of that chapter talks about what type of task classification work best, and there are 6 of them. One of them is, for example, emotion recognition through EEG data, or workload efficiency, looking at that EEG data. Those are the 6 top classification. And lastly, there are top three data input from EEG data. And the data input section of the EEG data that it covers the type of EEG data that works best as input data into the neural networks. One of them is frequency-based, obviously, another one is time-based, etc. And so it definitely gives you an idea as to what type of data input you need to think about. Because not only do you need to think about the type of EEG data input you need to have for the neural networks, but you also need to know what neural network architecture works best. All of that tailored towards the specific need that you have. So every single need is different. If you're, for example, interested in emotion recognition EEG data, obviously there's a difference between what type of neural networks that you can use and also what type of data. The last part, of course, is a conclusion about what this all means. So the book, if you get the paperback, it's only about 100 pages. So it's not that long. It's also very easy to read. I really made sure that it's very, very easy to read. So even if you have no background in any of these disciplines, you would feel very comfortable reading it. That's why I wrote it, and that's how I wrote it. And also, if you get it on the Kindle edition, I think it's like 500-600 pages, but that's just because it's Kindle, so the formatting is a little bit different. So I hope you guys enjoy it, and I hope you guys find it useful. Let me know if you have any questions, and of course, I always appreciate comments or reviews, hopefully good reviews, if you like. And yeah, definitely. Well, thanks for listening. I'll see you guys next time. Bye.